Welcome back to Learning with me, Ms. Killen, here at MPB. We've done it. We have come to the end of Unit 9. We're in our last lesson. So here we go. Got one more lesson to do. Hang with me. We're going to get through it. So here we go. We're at Lesson 6 of our Unit 9, even and odd functions. I can recognize even and odd functions using their expressions and analyzing their graphs. We're looking at F, BFB3. So let's go ahead and look into this. Now, we have some new vocabulary. Some of it's new, some of it's not. So what I want us to do is where we're keeping up with our vocabulary, we need to make sure that we're putting these down. Just even though if it's a review, we still have that indication of this is important. What symmetric means, what our origin is. We know what our y-axis is. What's opposites? We're looking at open circles and closed circles. So we need to make sure that we're remembering what these are. So here we go. What is an even function? Okay, it has symmetry about the y-axis. The graph is a mirror image across the y-axis. If you fold the graph along the y-axis, both sides will match. It still passes the vertical line test. So now that we have some indications of what an even function is, let's look. What's an odd function? An odd function, it has symmetry about the origin. Rotating the graph 180 degrees around the origin will leave it unchanged. So if I turn it a half a circle, it's still going to look like it did. Also, the domain must be symmetric around the origin, or 0. If x is in the domain, so x is negative x, it also still passes the vertical line test. Remember, all these functions, they must. Vertical line test, it's got to pass it. It's got to. So here we go. An example of an even function. Now let's look at this. The domain of the function must be symmetric around 0 or the origin. If x is in the domain, then negative x must also be. So here we go. This is, let's say that's 1, 2, 3.5. So a positive 3.5. I also have negative 1, negative 2, negative 3, negative 3.5. So when you have your x in these even functions, you also have to have your negative x in these even functions. Plugging in the negative input yields the same output. So you need to make sure that my output is 0 because that's my y value. So comma 0 is the same as putting that input in, and you still have the same output. So that's what your even functions are looking like. Let's look at this odd function, an example of an odd function. The domain must be symmetrical around the 0 or the origin. If x is in the domain, so is the negative x. Negative inputs yield the negative of the output. So let's see this. So I have right here is 1, 2, 3, 1. So if I have the negative 1, 2, 3, this is negative 3 down here, so this would be negative 3, negative 1. So if I put in the negative of my input, I got the negative of my output. So that is a wonderful example of my odd function. Even, odd, or neither. Okay, so my even, we said I folded across my y-axis. It's going to be right on top of each other, excuse me. It's just like if I did hot dog style. Remember that? So then my odd, remember, if I turned this 180 or half a circle, it's going to lie back on itself. Now, neither. I can fold it, I can twist it, I can tie it up with a bow, but it's still not going to resituate itself. So this would be neither. All right. Equation explanation. My even functions. If a function's even, then f of negative x equals f of x. To determine if even or odd, sub negative x into the equation. If the result poly is the same, then it's even. My odd. If a function is odd, then f of negative x will equal negative f of x, meaning my output's going to be negative. If the resulting poly is the exact opposite, then the function is odd. If the resulting poly is neither the same nor the exact opposite, the function is not even or odd. So if you got 3 and you plug all the stuff in and you get like a negative 21, it's neither. You're not getting the same or you're not getting the opposite. It's neither. So that was a good explanation. You may want to put these down in your notes so you've got exactly what substitutes as even and what substitutes as odd. And then if you get neither one of them, it's neither. So here we go. Let's do some practice. Complete the table. So I have my functions, I have my f of negative x, and then I'm telling if it's even, odd, or neither. So I'm going to work it up here on the board, you work it on your paper, and let's see what we got. So here we go. So I have f of x equals x squared. So I'm going to change that into f of negative x squared equals f of x. So what I'm doing is I have a negative times a negative, and I get a positive. So I'm going to have even function. So let's look at the next one. So I'm looking at taking my f of x equals x cubed and making it to that f of negative x. So I've got f of negative x cubed equals negative f of x. So I've got that negative times a negative equals a positive, and I still got to multiply that negative one more time, so that's going to give me a negative. Therefore, I'm going to get an odd. I'm getting the exact opposite. Therefore, I've got an odd function. I got another even, therefore, I got the same, so I have an even function. So let's look and see what else we've got. If a function is a polynomial with only even powers of x and no other terms, then it is an even function. So we need to take note of that. We need to write that down. That is very, very key to understanding these even and odd functions. If we don't have the graph and we just have an equation, this is going to help us determine even, odd, or neither. So then it says if a function is a polynomial made up of only odd powers of x and all coefficients are real, that is important, then it's an odd function. We want to make sure that we've got these two notes down on our notes page or wherever we're taking notes, because these two are going to help us determine if it's even, if it's odd, or if it's neither. So here we go. Time for you to master. Use the following functions to determine if the results are even, odd, or neither. So we're using functions f of x, h of x, and m of x. You're multiplying, you're adding, and you're adding. So I want you or you and your table partner to work these. Pause the video. Once you get done, come back. Let's see what we got. All right, so what we're going to do is we're going to put the functions into the operations and see what we get. So here we go. Let me grab a color. Let's use black. All right, so my first one, I'm taking f of x and multiplying it to h of x. So I have x squared times x to the third. When I multiply my coefficients, I add my exponents. So I have x to the fifth. That is an odd exponent, so I have an odd function. Now I'm taking h of x, multiplying it to m of x. Now, I am taking that one term and multiplying it to that binomial, so I can always write it like this. And this way, I know I am distributing. So I have x to the sixth minus 5x to the fourth, because remember, when I multiply, I add my exponents. So I have even, so it's going to be an even function. All right, so then let's look at this one. I've got f of x, which is x squared, and I'm adding it to what? M of x, which is x to the third minus 5x. All right, I have to keep my like terms together, so I have x to the third plus x squared minus 5x, or more importantly, I can write over here and you can see. So then I have an odd, which is 3, an even, which is 2, and an odd, which is 1. So they're mixed. So since they're mixed, it's going to be neither, because they are mixed. I have a 3, a 2, and a 1 as my exponents, so it is mixed. So let's try the last one. I'm looking at x to the third, and I'm adding that to x to the third minus 5. So 1x to the third plus 1x to the third is 2x to the third minus 5x. So I have a 3 and a 1. Those are odd. So So it's not necessarily difficult, it's just I've got to make sure I'm looking at those exponents and making sure I'm doing the correct operations. So, did your work look like my work? If not, turn to your proctor and say, hey, this is what we did wrong, or this is what I did wrong. What did you get? You know, compare and make sure that you are understanding what we did to get these. Good job. We don't want to forget with our even or odd, we have symmetry about the axis or the origin. We still pass the vertical line test. The results can't be neither even or odd. It just can be. It doesn't have to be even or odd. And we are always looking at our exponents to help us explain our results. We have come to the end of Unit 9. We have reviewed all these different functions. I have had a great time. I hope you have. I hope you're learning. I hope you're enjoying our math. So, as always, I am Ms. Killen here at MPB. Have a great day.